So first I'll introduce myself. My name is Fahad. I work at Travix, and there I get to do a lot of reactive programming with RxJS. We use React in production, so I'll also tell you like how you can use RxJS and embrace it and benefit from it, and use it either in React or Vue, doesn't matter. So before I start, I also would like to know that how many of you actually use React and Vue or Vue like in production right now? Okay, that's a good amount of people. And what about RxJS? Do you use it in production? That's less. That's good. So I'll briefly explain like what to expect in this talk. So first, we will learn to very quickly think about data streams, like what reactive programming is all about, and then why RxJS is so valuable to us and how we can benefit from it. And since React and Vue are like both component-based frameworks, and how streaming of data can, sorry? Oh, I don't know. So organizers, can you help, please? Okay, we can start again. Yeah, no worries. So then I will talk about like the benefits of combining Rx into your components layer, either it's React or Vue, doesn't matter, and then how you can use it in production, like once you leave this room, let's say. So it's very important to like understand like what reactive programming is. I'll cut all the BS and I'll just code Andres Stahls because that's whom I learned RxJS from. So he says reactive programming is programming with asynchronous data streams. Now you can ask me like, what is a data stream? Like as a JavaScript engineer, like we can understand what synchronous and asynchronous is. So what's that? So anything that you can like plot against time can be considered a data stream. So that's like the easiest way to like visualize it. But I can give you like a real life example, like based on the number of people in this room. So let's say there are like 100 people in this room right now. So the total count is 100. So my good friend Ricardo, who is like sitting somewhere in the back right now, so he really had some spicy Indian food last night, and he needs to rush to the toilet at this very moment. So he leaves the room, and immediately the count is like affected. So it becomes -1. So 100 minus 1, 99. Then after some time, he comes back and joins us again. So the count becomes 100 again. So this is something that's actually changing over time. So first it was 100, then it was 99, then it became 100 again. So how can we actually visualize this in a diagram? The RxJS community has established a concept called marble diagram. So it's basically ASCII art that you can like see in a timeline. And you can see that timeline only goes like forward because time moves only forward unless you can manipulate space-time. So these are the values that are emitted like A, B, C, and D. And X is actually says that, okay, there has been an error in your stream somewhere. And the pipe character that you see means that, okay, the stream has ended. It's very likely that sometimes the stream doesn't end. It just keeps on going, but the pipe is there if you want to use it. So the previous example that we just talked about, like the total number of people in this room, so you can visualize that in this diagram. So on the first minute, the total count was 100. Then on the 5th minute, my friend Ricardo left the room. It became 99. And then on the 20th minute, he comes back. It becomes 100 again. And then when the talk is over, there's a pipe here. It means that the stream has ended. So this is all good theoretically, but how can we actually express this in code? That's where the concept of observables come in. So, but what is that? Like, what does it even do? So it's a new type in JavaScript. Currently, it's being standardized by the TC39. And so how many of you know about promises here? Okay, everyone, great. So with promises, you actually emit the value only once. So you construct a promise, and you have access to resolving it with a value or reject it. That's it, it ends. With observables, you can like emit multiple values over time. So it's not just once. It can be like 0 values, 1 value, or more than 1. And it can also optionally finish or keep on going. And so it's like a stream. And you can have like multiple streams of data, things like that, combine them, operate on them, things like that. And also one of the biggest difference between an observable and a promise is observables are lazy. So unless you subscribe to it, nothing really happens. It just sits there idle. And promises are like always eager. So as soon as you call it, it's actually executing the stuff. It's doing its thing. And another very important thing is it can be canceled. Promises cannot be canceled. So imagine like you are fetching some request, but your component has been unmounted and stuff. So that request is still being handled by the component, but you just want to cancel it. With promises, you actually cannot do that. So observables can really help. It's very, very functional, so you can compose them, like do lots of stuff with it, and I'll show all of it to you in my later slides. So imagine observable is like supported in the browser today. This is what it would look like. Just like promise, you can like construct it, like new observable, and inside it, you have a function that you can pass, which gives you access to the observer object. So there's a difference between what an observable is and an observer. So observable is something that you can subscribe to for getting the values. An observer is something that actually generates the values for you. So here you can say that you can only generate the values inside the constructor, so no one outside of it can like impact it. Here, it's like just a number stream, and one other thing I need to mention is it's a convention in the community to like always end the variable name with a $sign to make you feel like, okay, this is actually a stream, so I need to work with it this way. And so here you have the observer, and it can have 3 methods. So if you want values to be like emitted out, you call observer.next. So I'm emitting like 3 values sequentially. It can be asynchronous too, doesn't matter. So 1, 2, and 3. And if I happen to have an error, I can do observer.error and send my error message there. And optionally, if I want my stream to end, I can call observer.complete, and then it just ends. That's all the basic example. And but that's just a definition, like how do I actually get the values and use it? You can get the number stream, which we defined in the previous slide. You can subscribe to it. And the first argument that you receive is actually the actual values that are being emitted, which is like all good. I'm getting all the numbers sequentially. I can log it to my console. And then there's an error handler saying that, okay, if there's an error, I just get it and it stops right there. Then, of course, the third one, which you can pass to know, okay, this observable has actually finished, so there is nothing more. And it will maximum fire only once, or never. When it comes to implementations, we can look into 2 options. One is Zen Observable, which is like a very minimal implementation of the TC39 proposal. And then there is RxJS version 5 and above, which is a very close implementation of that. But it's a lot more than that, of course. Like, it's not just a proposal. So the reason for going for this is because we cannot use it in the browser right now, so we have to use some libraries to support it. Before we get into RxJS, like, let's understand what Rx is all about. It stands for Reactive Extensions. It's an API for working with like asynchronous data streams, which can be expressed as observables. And also, the whole concept is like cross-platform. So you can use it in like Swift, you can use it in .NET, Java, and also there is a JavaScript implementation, which is RxJS. So RxJS is basically just for JavaScript. And from V5, it's actually a closed implementation of the TC39 proposal. And also, it comes with a lot of utility functions, like not just creation of observables, it also has more types that is similar to that. And also lots of operators, which are just like functions, accepting the observable, returning a new observable, like function in, function out. And so it gives you all of that. And so this is what I was talking about, like it helps you create new observable streams for like with constructors, or like from intervals, from Node.js style callbacks, a lot of ways. And then you can also like use functions like merge, concat, things like that for merging multiple streams into a single stream. Then you can subscribe to it once and just deal with it. And then there is operators for like transforming the streams. For example, if you're into functional programming, you would know about map, filter, reduce, things like that. So you can do all of that now asynchronously with streams. How awesome is that? So before I go into much deeper code, I want to say like why it makes things easy for us. As front-enders, like we deal with a lot of complex applications, like real-time applications that is dealing with sockets, always messages coming in, and to react to it in the web page without actually reloading the page. And then there's, of course, like things like cancellation of streams. For example, there's a component that's loaded, it's requesting something from the server, but before the request has completed, the component has already been unmounted because the user has moved on to something else. So what happens to this component then, like when the request actually resolves? So many things that can break. But with cancellation of streams, it becomes so much easier. So as soon as the subscription is over, there is no side effects anymore. It's like done, like it's gone. And also, as front-enders, we also deal with now applications that supports offline thing. So what happens is like the user gets disconnected, so my application should be smart enough to keep trying to connect to the server, saying that, okay, the internet is back or not, and then I want to fetch from the new data from the server again. So this involves a lot of retry logic. This is also something that RxJS can handle very well. So you can say that, okay, the stream has failed, so let's retry it 5 times or something more, and then try it again. So you can just define it in one place, like in declarative programming, and it will just do the thing for you. So that's really awesome, because it's like a lot of peace of mind for me. And just to give you an idea of like operators work, this is like a very basic example, so I don't have much time to explain everything. So this is our number stream. So imagine this number 1, 2, 3, 4, and 5 are like coming in asynchronously, like first second, after 10 seconds, 20 seconds, doesn't matter. And then I'm saying that, okay, I don't want all the numbers. I want to filter them. So I only want the odd numbers for the next stream. So I apply this filter operator. So it's much like how arrays work actually, but for streams, which is asynchronous. So for filter, I'm saying that, okay, if the remainder is 1, then only continue to the next stream. Then I have the filter stream here, which only has 1, 3, and 5. But I'm not happy with that yet. I still want to process it more. And then I said, okay, I want to map it more to change the values a bit differently. So I multiply them by 10, and it becomes 10, 30, and 50. This is all in marble diagrams. How does it look like in code? So RxJS has this huge list of operators that you can choose from. So I'm just keeping it simple by importing filter and map. And I already had this numbers stream in by previous constant somewhere. And I can use this pipe method. So this is something new that was introduced since RxJS version 5.5. So instead of like loading all the operators together in your bundle, you can only import the functions that you specifically need for your application, and only that goes into the bundle. So your bundle size from, let's say, a few 100 kilobytes becomes like only 3 or 4 kilobytes. That's really a big thing that happened in RxJS. So how we can use the pipe operator is we can pass a list of operator functions by calling them. So we can say that, okay, we have this number stream, this is the pipe, and we pass the filter operator, we pass the predicate, like how it should process it, and then we also have the map that takes the incoming values, maps it. And then when we subscribe it, we can subscribe to the result stream. And it will look like this. We just subscribe the incoming numbers, and they actually convert from 1, 2, 3, 4, 5 to 10, 30, and 50. That's how operators basically work. But I also told before that RxJS is more than just observables. It also has some additional types. I'll just talk about one, subjects. So before, in our examples, we noticed that we only generate values from inside the constructor of the observable. So no one from outside can actually add more values to the stream. Subjects come here to help solve that problem. And why you need that? Because, for example, you have this observable here, and you have this button component right here. And the button component wants to like send some events back to the observable that may emit new values, and those values can be passed as props to your component. So it's like an unidirectional cycle. So subjects help you achieve that. And the code-wise, it looks like this. So we import subject from RxJS, and we construct it, and nothing actually has happened yet because it's still an empty stream. So we subscribe already because it's an observable type. So it has a .subscribe method. And whenever there is some new value, it will keep logging it to the console. But that's not all, because subject is an implementation of both observable and observer. So it means that it has the method of observable, which is .subscribe, and it also has all the methods of observer, which has like next, complete, and error. So here you can see, like, once I have defined my subject and also subscribed to it, then I am emitting new values. So once I call these, it will actually trigger these 3 times. And then I can see in my stream that it's 1, 2, 3, and since I'm not completing it, it just keeps on going. Whenever there's new value, it will be like logged. So that's subject for you. And I'll stop for RxJS a bit right now, because I need to move on to the components layer. So there's a reason I chose more than one rendering library for this talk, because I really wanted everyone to be able to just think in data streams where all the logic is applied, and then you can just direct that stream anywhere. Either it is React or Vue or Preact, doesn't matter, because that's just for the presentation layer. All the logic can belong to the RxJS domain. What is the most common thing that you have in the rendering libraries? They receive props and they render themselves. If they receive new props, they re-render themselves. So in a way, they are reactive in their own way. And how can we leverage the power of RxJS, which is all about observables, with these libraries? Think of props as a stream. What if you could just stream new props to your component, and your component just receives them and just re-renders itself? How awesome would that be? all of the components can actually become just stateless all the time. So just to give you like a... That was not me. uh, I don't know what's happening, actually. Sorry about that. Yep. Okay. We'll try. Okay, so on the left side, we have RxJS observable. So let's say it streams new props, and it goes to your component. This, I'm using the React logo. Think it can be view too. So, but that's just one way, like direction, like it's just giving props. But I also need to be able to like accept events coming from the component, because components can have events like on click, on mouse over, things like that, or input field. So how do I do that? Because observable itself cannot accept new values. Let's convert it to subject. So here, I'm illustrating an example of an input field. So imagine someone is typing something, and then the data gets sent back to the subject. Subject is processing it asynchronously and then sending the value back to the component in an unidirectional way as props. So it starts with an input value, that is, let's say, an empty value for a name field. It gets to React, and the user actually updates the value in the browser, and React sends it with a handle change event handler, and then it goes back to subject. And subject then sends the input value back to React again. So it just flows. It's like a controlled input. And with this, you can actually even handle things like validation errors and things like that on the top level. So imagine every time there's a new input, you're actually asynchronously doing something else by checking some data from the server and seeing, okay, if this input value is unique or not. And then you can even stream the validation errors to the component again. So all the component does is just receives the props, and if there's any handler, just pass it back to the subject. This, again, is, OK, so we talked about that. So now I'll give a very simple example. Imagine there is an interval component that receives the prop interval, and we expect that that prop should be like incremented every second by 1. And it should, so in the first second, the prop subject would be like interval 1, second, interval 2, and then third, interval 3, and then 4, 5, it just keeps on going. So this stream can be expressed with RxJS using this code. So import this interval function from RxJS directly. And when we call it, we actually get a stream saying that, OK, give me an incrementing number every 1 second. So this is 1,000 milliseconds. But that's not enough, because that just gives us the integer to us. What we need is something that's compatible with the props object that our components can actually understand and use it to render. So what we do is we also import this operator called map, and then apply it to our interval stream, saying that, OK, every time you give me an integer that is an n, convert it to an object which has an interval key, and then the value n. Now we have the prop stream ready. Now it's a matter of like connecting it to our component, and we should just be done. So if we just subscribe to it like normally, it would be like this. These are the objects that will be like generated every time for you. If you used that stream in your existing raw React or Vue component today, it'll be something like this. That's a lot of code. And that doesn't really make me happy at all. Imagine like you have to initialize your component, either React or Vue, with like internal state. And then when the component mounts, you actually need to subscribe to your observable. And then when new values are being emitted, you actually have to save that in your internal state. And then the render function will like actually get those local state and then render it. Same thing is happening here. I'm using JSX, so it's like easier to read side by side. And that's not just all. Also, when the component unmounts, both here and here, you also need to be able to like cancel that subscription so that there is no memory leak. That's a lot of things to remember. Like that's too much. So I really wanted to change that. And also, what my idea is, I have my stream, I have my stateless component. They should just work together somehow by just connecting with a function or something. It shouldn't be more complicated than that. So let's first start with this. Like this is our base component. Like that is just stateless, nothing more. On the left side there is React. On the right side there is Vue. And you can see that both the components are receiving props, and the props has an interval key. And we expect that there will be new props every second. It will keep incrementing. But where is RxJS? Like, it's nowhere here. So imagine this is your module. You already have your prop stream defined. You already have your stateless component. And I expect that there is some sort of a magic higher order component that I can just call to link both the stream and the component together. And I want to be done. I don't want to know anything more. So that's something that would make it ideal for me. Like, it would make me want to use RxJS because then I don't have to write too much code. But I mean, there's still going to be like lots of solution later on, but what benefits do I get though? Like, why should I even do this in the first place? First is your code becomes extremely functional and it becomes like easier to read. You can just go from top to bottom because it's not like internal state management back and forth that you have to understand like how the flow is. You just read from top to bottom and you understand right away what it does. And also, there's a clear separation between logic and presentation. So all the logical stuff, the behavior of your component and stuff like that, actually lives in the RxJS area, like with all the streams. And the components are just stateless. They just receive props, render it. That's all they do, nothing more. And since your components actually become stateless, either in Vue or React, it actually becomes much more easier to unit test them. So that's also added benefit. Again, we don't know how to connect them. So there are some existing solutions. So first, there is a Redux observable, which is really awesome. Like, if you use Redux with React right now, you can just go for Redux observable. And they have a concept of epics saying that, OK, it just receives all the dispatched actions as a stream and then reacts to it differently. And then all the components which are like connected to the state can just like react to the state itself. Then there's Recycle. Then there's VueRx, which can actually generate streams from within the component and then pass them as like data for the rendering logic. Then there's VueStreams. All of them are really great. And I have used them personally, like some of them. But they have some limitations, which I didn't fully like. They're all doing a great job, but still, I had more to desire. So the first one is, if you go for Redux, then you're actually binding yourself to a single store that is for your whole application. It has nothing to do with your single component. All I wanted was just a stream and my component. I didn't want to go for like a full application-wide thing. And then, of course, the other thing with solutions is like some can only generate new observables for you and then pass them as like props or internal state to the rendering logic. But this is also not nice, because if I want to go full RxJS, I also want to be able to like receive the incoming props, which are passed to me from the parent component as a stream, and then I can like pass a new stream. So it's like stream in, stream out, pure and functional. That would allow me to harness all the raw power of RxJS. So that's something that I found missing. And I really wanted to like do something that solves that. So we already have this prop stream and the interval component in our module. So we import these two functions. One is withObservable, which is a function from propy, saying that, OK, this is my source, convert it to props. And then this higher order component called attach that takes the composition and then connects it to your base component. Can you find any difference in these two? On the left side, there is React. On the right side, there is Vue. The only thing that changes is the name of the package, where the higher order component is like imported. So this one is propy React, this one is propy Vue. And here, I'm saying that, OK, attach my component with these settings, like the composition, like with observable. And here, I can return a stream from a function. But still not doing enough. Like, I talked about, like, OK, what if we want to be able to like receive incoming props as a stream and then return a new stream that our base component can receive? Then our code can improve a bit more. So we have a very Rx-specific package for like generating props. It's called withStream, and this one actually allows you to access the incoming props as a stream, and you can return a new stream. Here, you can say, so in a live example, I would say, imagine you have a component that is mounted based on a route, and it has a parameter in the route called product ID. And whenever this component is mounted, you need to be able to get that product ID and fetch some data from the server based on that ID. So that's an asynchronous process. So imagine the user has navigated to something else while the request was in progress, and the prop changes. So it's a second product now. From product ID 1, it became product ID 2. So you can handle that with RxJS as an incoming stream and say, OK, my prop ID has changed. Now I want to cancel everything that I was doing before and request this new thing. So I can return a new prop stream, and it will just immediately go directly to my base component. So that's how it can all connect. And There are also some advanced use cases supported, because if you go full RxJS, it becomes all like asynchronous, and your server-side rendering will really suffer for that. So this package also takes care of like generating some static props on the server side, where you can generate all the values before you actually go for rendering. And then it will just like render with the data, and it will be shipped to the browser as just raw HTML, and React or Vue can just pick it up from there. So all of those things are also covered. There are also another thing, for example, you have some application-wide settings and configuration that sometimes you want to be able to access from components. That is also supported with this library. So imagine you have a configuration that has URLs like, this is my API endpoint, and this is my theme, dark or light, something like that. Even Redux store, that's a very good example. The store itself can also be accessible with this composition. So before I end my talk, I really want to say like Rx is like really, really heavy, and it has a steep learning curve. So please don't choose it just because others are doing it. Have some really established use cases first. Like if you really struggle with like asynchronous data streams and things like that, Rx is awesome. It will make like the hard things very, very, very easy. But if you just use it without thinking, then it's also possible that it will make the easy things very hard for you. So choose wisely. And thank you. And yeah, that's it.